Imagine yourself standing upon a vast beach at dawn, where the waves murmur ancient secrets, and the expansive sky above seems to embrace the entire cosmos. You might scarcely believe it when I relate this, but the Earth, our verdant home, is in truth merely a minuscule speck of dust, a fleeting aberration within the grand tapestry of the universe. For the entirety of human history, encompassing all its joys, sorrows, discoveries, and conflicts, occupies but 1/10,000th of 1% upon the cosmic timeline. Should you remain skeptical, I am prepared to wager 15 seconds against 13,800,000,000 years. Today, let us compress the entire 13,800,000,000 year history of the universe into the mere 365 days of a single year and explore what it would resemble. When were the sun and the earth born? And perhaps the aspect that will most chill you to the bone is the moment when humanity emerges, a brief flicker amidst the infinite darkness. Upon this scale, 1 second equates to 437 years and 6/10ths of a year. Thus, let us rewind to the origin, midnight on the 1st of January, when the universe commenced with a tremendous explosion, a mysterious instant that scientists such as Edwin Hubble and Georges Lemaître devoted their lifetimes to unraveling, thereby opening the gateway for us to comprehend the genesis of all existence. At that precise moment, the universe sprang forth from an infinitely dense and scorching singularity, where all familiar physical laws disintegrated, then expanded with extraordinary rapidity at velocities exceeding that of light during the phase known as cosmic inflation, a concept proposed by the physicist Alan Guth in the 1980s, which elucidates why the universe today exhibits such remarkable uniformity across vast distances, as confirmed by observations from the Planck satellite and ongoing analyses up to 2026, suggesting that this inflationary epoch smoothed out initial irregularities to create the homogeneous cosmos we observe. In those initial instants, the universe was so intensely hot that even the tiniest subatomic particles could not coalesce, resembling a chaotic broth of pure energy, with temperatures soaring to trillions of degrees, and an atmosphere so oppressive that one could sense the weight of creation itself bubbling forth. As time progressed, the universe cooled sufficiently for quarks and electrons to emerge, serving as the foundational building blocks of matter, the fundamental particles that physicists like Murray Gell-Mann described through his quark model in the 1960s, enabling us to grasp how the universe constructed itself from its most basic components, with recent quantum simulations in 2026 reinforcing the stability of these particles under extreme conditions. These quarks subsequently combine to form protons and neutrons, the very constituents of our own bodies, reminding us that we are not strangers to the universe, but an integral part of it, woven from ancient elements that trace their lineage back to this primordial era. Upon our cosmic calendar, at 14 minutes and 28 seconds on the 1st of January, the universe had cooled adequately for electrons to be captured in orbits around atomic nuclei, forming the initial atoms of hydrogen and helium, a process termed recombination, which transpired approximately 380,000 years after the Great Explosion, according to data from NASA's Wilkinson Microwave and Isotropy Probe. This event liberated the universe's inaugural light, which we can detect today as the cosmic microwave background radiation, a faint echo from the dawn of time, measured by scientists such as George Smoot, who received the Nobel Prize for this discovery, revealing that the universe was once a uniform sea of fire, with precise mappings in 2026 from the Atacama Cosmology Telescope affirming its near-perfect isotropy. Nevertheless, no stars yet existed. The universe was suffused with a dim orange glow, akin to an extended twilight, persisting for about 3 million years before shifting to invisible wavelengths, whereupon the universe plunged into a prolonged obscurity, entering the period known as the Dark Ages, during which gravity silently operated in the shadows, aggregating gas into the first clusters. On the 8th of January, a wondrous occurrence unfolded. Amidst the residual gas and dust from the Great Explosion, gravity, the force that Isaac Newton described in his laws of motion, and which Albert Einstein refined through his theory of general relativity, began to exert its influence. forging the inaugural generation of stars, colossal entities that formed roughly 100 to 200 million years after the Great Explosion, as per models from the Harvard-Smithsonian Center for Astrophysics. These stars differed from our Sun, composed of 75% hydrogen and 25% helium, and they functioned by fusing lighter elements in their cores to produce heavier ones, such as carbon and oxygen, the elements prevalent in the modern universe, including metals, a mechanism termed nucleosynthesis, explained by Hans Bethe in the 1930s. As these were the very first stars, with no prior means to generate heavier elements, they possessed masses dozens of times greater than the Sun, yet lifespans shorter than 1 million years, culminating in resounding supernovae that dispersed heavy elements throughout space, like seeds for future life. Owing to their antiquity compared to contemporary stars, we have yet to observe any of these enigmatic first stars directly, although the James Webb Space Telescope has recently detected signatures of them in 2025, according to NASA reports, including potential population 3 stars in distant galaxies, and evidence of early supernovae from gamma-ray bursts, igniting curiosity about these spectral luminaries that illuminated the cosmic darkness and may have seeded the formation of the universe's first supermassive black holes, as detailed in studies from 2026. On the 19th of January, the universe brimmed with radiant stars erupting into supernovae, while gravity tirelessly labored, commencing the formation of the initial galaxies, immense structures that Edwin Hubble classified in the 1920s, initially diminutive but gradually expanding through mergers with neighboring galaxies, resembling a languid dance of unification. A few days thereafter, our own galaxy, the Milky Way, came into being approximately 13,600 million years ago, according to data from the European Space Agency's Gaia mission, a spiraling system teeming with hundreds of billions of stars, wherein we occupy but a peripheral speck. At this juncture, the universe's age equated to merely 6% of its current span, and the exquisite structure of the cosmos that we behold today, the cosmic web with its visually intuitive form akin to neural pathways in the human brain, a parallelism analyzed by researchers from the University of Bologna in 2020 and reaffirmed in subsequent studies up to 2026, indicating that the universe and the brain may adhere to analogous organizational principles, such as power law distributions in connectivity, manifests as threads linking galaxies together. Gravity clustered these galaxies, which continued to evolve, forming the superclusters we observe in the contemporary universe, an enormous lattice termed the cosmic web, captured recently by the Hubble and James Webb telescopes, with the largest filaments discovered in 2025, as reported in Science News, prompting us to ponder whether the universe might be a vibrant entity in its own right. On the 11th of April, the first stars resembling our Sun began to form, and within these stars resided heavier elements such as iron and carbon, permitting planetary systems akin to our own to commence formation, featuring rocky planets of the Earth-like variety, a pivotal turn that astronomers like Sarah Seeger have investigated through exoplanets. This likely marked a transformative moment in cosmic history. For the first time, planets capable of harboring life embarked upon their journeys, inaugurating a novel epoch in the universe, where life might sprout from primordial oceans, as on Earth or perchance on other worlds. On the 1st of September, our Sun and the nascent solar system began to take shape approximately 4,600 million years ago, according to lunar rock samples, a protostar born from a cloud of gas and dust, and the giant planets such as Jupiter, Saturn, Neptune, and Uranus also commenced formation, with Neptune and Uranus positioned nearer the inner solar system than today, per the Nice model from French scientists. Some astronomers even posit that during this phase, one or more giant icy planets formed and were subsequently ejected from the solar system, akin to the legendary 9th planet that Mike Brown continues to seek. The Sun ignited for the first time, initiating the fusion of hydrogen into helium, commencing its approximately 10 billion-year life cycle, a stable nuclear furnace providing light and warmth for life. Merely 2 days later, the rocky planets began to coalesce. Earth, Mars, Mercury, and Venus are names familiar to us, but what of Theia? Theia was a planet within the solar system, roughly the size of Mars, and once held the potential to become a second Earth. Yet a cataclysmic collision occurred approximately 4,500,000,000 years ago, according to simulations from NASA in 2022, with Theia hurtling into our youthful Earth with unimaginable force, flinging debris across space, the impact resounding like a primordial roar. From those remnants, Theia endured, but no longer as a planet. Instead, it became our moon, a satellite that stabilizes Earth's axial tilt, engendering tides and seasons. After approximately 22 days upon our cosmic calendar, through successive cycles of volcanic eruptions, rivers of incandescent lava akin to the planet's blood, ice ages with thick sheets enveloping the surface, and earthquakes shuddering the crust, a miracle transpired. As far as we know, life first appeared in the entire universe, born within the profound oceans of this young planet, approximately 3,700,000,000 years ago, according to stromatolite fossils from Australia and Greenland. The prevailing hypothesis suggests that life originated near hydrothermal vents on the seafloor, where immense pressure, coupled with interactions between vent fluids and seawater, could react with minerals to produce the initial organic molecules, the bedrock of all life on Earth. An idea explored by Nick Lane in his works on life's origins, with recent 2026 research on giant viruses like Ushiku virus, offering clues to how complex cells may have evolved from simpler precursors, and studies re-evaluating the sequence of amino acid formation to better align with prebiotic chemistry. These earliest life forms were prokaryotic single-celled organisms, and similar conditions exist elsewhere in the universe. Indeed, they persist within our own solar system today. Saturn's moon Enceladus and Jupiter's moon Europa are known to harbor vast liquid water oceans concealed beneath thick ice layers, with plumes ejecting organics, according to data from NASA's Cassini and Europa Clipper missions in 2025, suggesting that life might be emerging at this very moment in those oceans, akin to its appearance on Earth. Or perhaps it already has, with scientists like Sarah Amari Walker theorizing about chemo-autotrophic possibilities on Europa. Though recent analyses indicate Europa may lack sufficient underwater geologic activity for robust hydrothermal systems, while Enceladus shows stable heat flow and newly detected organics in 2026, enhancing its habitability prospects. As we advance towards year's end, numerous pivotal milestones are established in succession, like a symphony escalating in tempo. On the 3rd of October, the initial photosynthetic bacteria emerged, initially absorbing infrared light rather than visible and producing sulfur instead of oxygen, a gradual evolutionary step within the warm oceans. Later that month, on the 21st of October, an entirely novel microorganism, the cyanobacteria, began to perform its wonder, utilizing sunlight, carbon dioxide, and water to manufacture sustenance through photosynthesis, with oxygen as a byproduct, a process that Jan Ingenhousz discovered in the 18th century. This was the crucial instant. Earth's oxygen supply inexorably increased, first saturating the oceans, then spilling into the atmosphere approximately 2,400,000,000 years ago during the Great Oxidation Event, bestowing upon us the breathable air and transforming the planet from an anoxic world into a verdant one, according to research from the University of California, with 2026 molecular clock analyses revealing that some bacteria utilized trace oxygen long before cyanobacteria's proliferation, and evolutionary studies tracing multicellularity genes in cyanobacteria leading up to this event. Life commenced rapid evolution, microorganisms engaging in symbiosis, forming unprecedented complex life forms, such as the endosymbiotic event proposed by Lynn Margulis, wherein mitochondria and chloroplasts became integral to cells, a theory bolstered by 2026 research viewing eukaryotic emergence as an algorithmic phase transition in genetic architecture, quantitatively explaining the leap in complexity. Finally, on the 17th of December, fish began to evolve in the oceans approximately 500,000,000 years ago, developing crania and vertebrae, gliding through the azure depths. At 2:15 in the morning on the 20th of December, the first sharks commenced swimming in the vast oceans, approximately 450,000,000 years ago, primordial predators with razor-sharp teeth, their fins slicing through the water like whispers of resilient life. Merely 9 hours later, the first trees appeared upon the Earth, approximately 385 million years ago, signifying that sharks arrived on the planet before trees by about 30 million years, a peculiar fact from the Natural History Museum in London, astonishing us regarding the flow of time. The 22nd of December marks another significant milestone, when life at last began its gradual evolution to depart the water, with the initial creatures crawling onto land, inhaling the dry air, this being the inaugural step towards the immense diversity of large animals we witness on Earth today, a grand migration from ocean to continent. 4 days thereafter, dinosaurs and the first mammals arose, commencing their dominion over the land and spreading far and wide, with dinosaurs roaring through primeval forests and diminutive mammals skulking in the shadows. Around this period, the ancient supercontinent Pangaea began to fracture, approximately 200 million years ago, shaping the rudimentary outlines of the continents we behold and inhabit today, with earthquakes resounding like the Earth's size. At 6:38 in the morning on the 30th of December, the dinosaur's nemesis plummeted into the Earth, approximately 66 million years ago. This asteroid struck the region now known as the Gulf of Mexico at 20 kilometers per second, cruising the Chicxulub crater wider than 170 kilometers, according to data from Luis Alvarez and his son, who proposed the impact hypothesis. The collision unleashed energy equivalent to 10 billion times the destructive power of the atomic bombs deployed in Japan during the Second World War, utterly devastating the surrounding area, engendering a sea of fire capable of instantaneously incinerating vegetation thousands of kilometers distant, with the boom echoing across the planet. Earthquakes and tsunamis ravaged the globe, yet that was not the worst. An immense quantity of rock and debris was hurled into Earth's atmosphere, forming a thin veil of dust enveloping the world. Though this layer was merely about 1/10 of an inch thick, it was heated to extreme temperatures by the impact's kinetic energy, causing the atmosphere to rapidly warm. Nearly all life not subterranean or subaqueous, essentially all dinosaurs, swiftly perished from that horrific heat, their final cries mingling with the dusty winds. A thick pall of dust shrouded the Earth, obstructing nearly all sunlight from reaching the surface for years, precipitating a drastic temperature decline and harsher survival conditions, leading to 75% of species on Earth becoming extinct, and an entire diverse ecosystem vanishing forever. Though recent 2026 findings indicate that some ammonites, marine creatures akin to nautiluses, survived briefly beyond the impact before ultimate disappearance. Fortunately for us, our distant mammalian ancestors were among the few fortunate survivors, concealed in dark burrows, awaiting a new dawn. Now, place all this within the context of our cosmic calendar. The entire event transpired when the year had but 42 hours remaining, leaving us merely 42 hours from that harrowing scene until the moment you sit here reading these lines, a brief interval that stirs the heart regarding life's fragility. What ensues next will forever alter your perception of existence. 6 hours later, at 12:59 on the same day, our earliest primate ancestors appeared, approximately 65 million years ago, laying the foundation for human evolution, diminutive beings clambering through trees, gazing curiously at the sky. On the 31st of December, the final day of the year, matters truly accelerate, like a river rushing towards a cascade. At 10:15 in the evening, the genus Homo first emerged in Africa, approximately 2 million years ago, according to fossils from Mary Leakey and her family. 1 hour later, at 11:37 in the evening, the initial Homo sapiens arose, approximately 300,000 years ago, and humanity began to tread the earth, with those first footsteps upon the African savannas, feeling the wind upon their skin. When merely 23 minutes remain until midnight, the clock strikes 11:59. With 29 seconds before midnight, humanity invented agriculture approximately 12,000 years ago, transitioning from hunting and gathering to cultivation and settlement, erecting the first villages beside rivers. With 14 seconds before midnight, people in Mesopotamia invented the wheel and writing approximately 5,000 years ago, inaugurating eras of record-keeping and mobility. With 12 seconds before midnight, the Egyptian pyramids had just been completed, approximately 4,500 years ago, monumental edifices defying time. With 7 seconds remaining, ancient Greek philosophers such as Archimedes and Plato were still alive approximately 2,500 years ago, contemplating the cosmos. With 3 seconds before midnight, Nicolaus Copernicus had just discerned that the Earth is not the center of the universe approximately 500 years ago, a revolution shattering antiquated beliefs. And with but 1 second before midnight, the final 400 years of human history are compressed into that solitary, fleeting second, meaning that upon our cosmic calendar, the year's concluding second encompasses Galileo's invention of the telescope and his initial observations of the heavens, Newton's formulation of the laws of motion and universal gravitation, Benjamin Franklin's discovery of electricity, Darwin's theory of evolution, Einstein's theory of relativity, the elucidation of DNA structure by Watson and Crick, the outbreak of the First World War, the creation and deployment of the atomic bomb in the Second World War, the moment your parents met, the invention of the telephone by Alexander Graham Bell, the emergence of the Internet by Tim Berners-Lee, the discovery of Pluto by Clyde Tombaugh, the first heart transplant by Christian Bernard, the birth of artificial intelligence grounded in Alan Turing's foundations, your own birth, the Cold War, the Renaissance with Leonardo da Vinci, the complete works of Mozart and Beethoven, your first declaration of love, the first photograph by Joseph Nicephore-Niepce, the first film by the Lumiere brothers, the initial time you followed a narrative such as this, and the opening sentence of any journey whatsoever. All those occurrences transpired in a mere second, compelling us to realize that humanity is but a transient instant upon the universe's scale, a brief gleam amidst the infinite, yet profound and meaningful due to our curiosity and capacity for change. And within a broader context, theories such as the multiverse from Hugh Everett or anomalies in the background radiation from scientists like Roger Penrose suggest that our universe may be merely one among countless others, with parallel realities where everything might differ, evoking mystery about whether we are truly alone or part of a grander lattice, where consciousness might be a fundamental field, according to research in AIP Advances in 2025, positing consciousness as a bedrock of reality and exploring its implications for quantum mechanics and cosmic evolution. Finally, I extend sincere and profound gratitude to all the scientists, researchers, and collectives who have dedicated themselves quietly to this journey of cosmic exploration. From Edwin Hubble, Georges Lemaitre, Alan Guth, Murray Gell-Mann, George Smoot, Hans Bethe, Sarah Seeger, Mike Brown, Nick Lane, Jan Ingenhaus, Lynn Margulis, Luis Alvarez, Mary Leakey, Isaac Newton, Albert Einstein, Charles Darwin, James Watson, Francis Crick, Alan Turing, and innumerable others. Individuals whose persistent efforts and unwavering dedication have bestowed upon humanity invaluable insights, constructing the foundations of knowledge and inspiring future generations, enabling us to recognize our humble yet potent position within the vast cosmos.